Thank you for stopping by. Now look at this question. It says the limit of 1 minus cos x over x squared as x tends to 0, as x approaches 0. So now the first thing is to solve this first. Let us first apply the direct substitution. What do I mean by direct substitution? Anywhere you see x, you input 0. It says x is approaching 0. It means at the end of the day, x will definitely be 0 because x is going towards 0. So it means that what? Wherever we see x, input x. That is the first step first. So we have 1. Wherever we see x, input 0 rather. So we have cos 0 over 0 squared. Cos 0 is 1. That is 1 minus 1 over 0 squared is 0. 1 minus 1, 0 over 0. So this does not exist. This is indefinite. This is indefinite. I cannot afford to have indefinite as an answer. So what do we do then? So then there comes the method of L'Hospital's rule. So L'Hospital's rule. So what does this rule says? It says that whenever we have 0 over 0, what do? We are going to differentiate the numerator and also differentiate the denominator. That means we are what? We are comparing the speed of both. So now let us differentiate 1. Differentiating 1. That's what? That's 0. Whenever you are differentiating a constant, it gives 0. Let us differentiate sine. Cos x. So when we differentiate cos from our standard derivatives, it's going to give us minus sine x. Minus sine x. And when we differentiate x squared, it's going to give us 2x. So then, what are we going to have? So it's going to become our derivative of 1 is what? 0. So instead of writing 1, we have our 0 minus we have minus this minus. Our derivative of cos x is what? Minus sine. So minus times this minus, we have our plus, then sine x over, what is the derivative of this? 2x. So what do we do next? Now let's impute our x 0 whenever we see x. So we have limit as x goes to 0. So we have 0 plus sine, no, writing sine x, we have 0 over 2 times 0. So 0 plus sine 0 is what? Is 0. So we have 0 over 2 times 0, 0. That is 0 over 0. Still we are getting 0 over 0. So what do we do again? We are going to apply the L'Hospital's rule again. So this time around, we are going to be comparing the acceleration. The first derivative that we did, we compared the speed. Now we are finding the derivative again the second time. So in this case now, we are comparing the acceleration. So what are we going to differentiate? We differentiate these values, 0, sine x, and 2x. So what is the derivative of 0? The derivative of 0 is 0. The derivative of 0 is 0. What is the derivative of sine x? Sine x, that's going to give us what? Cos x. And what is the derivative of 2x? The derivative of 2x is 2. So we are now going to make use of this value now, this new. So it's going to become, instead of writing this 0, we have 0 in the derivative, which is 0, plus, what is the derivative of sine? Cos x, we have cos x over, what is the derivative of 2x? 2. So we have 2. Then we have our limit. Limit as x goes to 0. So wherever we see x, we put as 0. So we have 0 plus cos 0 over 2. We have 0. What's cos 0? Cos 0 is 1. We have plus 1 over 2. 0 plus 1, we have 1 over 2. So it means that what? The limit of this is 1 over 2. Thank you very much for watching.